Now, with these conversion problems, getting the equal sign, it's all about getting these fractions. And getting the fractions come from getting some kind of equals sign. But the question is, where do we get this equality formula? Essentially, here's what the problem is. I need to calculate the mass of 0.5000 moles of helium atoms. Now, first thing you're going to say is, why don't you just say 0.5 moles of helium atoms? It's the same thing as 0.5000. And my answer is, because the accuracy with those extra zeros, that makes a big difference. The second thing I have is, where am I getting this equality thing that I'm talking about? And here's what I mean. Remember, I had these equal signs right here, which led me to two fractions. And that fraction is the key, but I need to figure out what the equal sign is. Now, to find what the equal sign is, to match up moles to grams, the key here is to look at the periodic table. And the nice thing about the periodic table is, see this number right here? This is your molar mass. And so for helium, it's 4.0026. So for every 1 mole of helium, that is equal to 4.0026 grams of helium. And now I have a whole bunch of equality statements, because I can say 1 mole of nitrogen is 14.007 grams of nitrogen, or 1 mole of lead, plumbum, is 207.2 grams of lead. And then that implies that I have two fractions. I have one where I have the grams on top, and there's some number here, that would be the 4.0026, and I have 1 mole on the bottom, or I have the other one which has the 1 mole on top, and then I have that number 4.2006 grams on the bottom. I just was too lazy to write down that number each time, so that's why I just put the number symbol. Now I'm starting off with 0.5000 moles of helium, and I want to multiply it by some fraction, one of these two, so that in the end I want to have grams of helium. Now, which one am I going to use? The one on the top or the one on the bottom? The one with the moles in the denominator, or the one with the grams in the denominator? And the one I'm going to use is the one with the moles in the denominator, because the moles over here is in the numerator. So I want them to cancel out. I want those units to cancel out, leaving me with grams, which is a nice thing. So let me not be lazy this time and write it out. 4.0026 grams of helium divided by 1 mole of helium. And now watch what happens. My favorite step. See, this moles of helium cancels out with that moles of helium over here. And let's see, 0.5000 times 4.0026, that is 2.002 grams of helium, because my units that are left over is grams of helium. How many numbers do I want to report? Well, originally I was given 1, 2, 3, 4 significant figures, so I want 4 significant figures in my answer. 1, 2, 3, 4. And notice how I wrote down the molar mass, which is 4.0026, to have 5 significant figures. 1, 2, 3, 4, 5. And the reason why I did that is because I'm going to write the number as many digits as I need in order for it to be more accurate than what I was given, because I don't want to write down, let's say, 4.00 grams of helium if I'm dealing with 4 significant figures over here, and then I deal with 3 significant figures over here. That would cut my answer down to 3 significant figures. And essentially, I ended up cutting down the number of significant figures because I was too lazy to write down those extra units. But when I kept 5 significant figures over here, it didn't cut down the accuracy of my answer. It kept it as accurate as the final answer. And then all I did was I rounded off my number so that way it had the same number of significant figures as what was given to me, because I don't want any of my conversions to mess things up and cut down the number of significant figures that I measured to begin with. I hope that makes sense.